Hello everyone. In the discussion of the role of mathematics in industries and engineering, in this discussion we are going to talk about a unique concept called queuing models and its importance when it comes to real-time problems. So I think you all can view this. So what do you mean by a queuing model? Any idea? Queuing model. Why there is a requirement for queuing model? What do you mean by a queue? When there is more than one person for that service to be done and he is waiting somewhere. There we create a concept of queue. There we create a concept of queue. If there is a person who is in need of a service, it can be a bank, it can be a railway station waiting for the reservations or ticket or maybe in a barber shop waiting for a haircut. So like kind, if there is someone waiting for the service and we have to optimize the waiting time of the customer, and we have, see, if you are going to a shop and if you are told to wait maybe for 2 minutes, for example, let us assume we are going to a restaurant, right? We are going for a restaurant and we are going to ordering something. He takes 1 hour to bring the dish to you. What do you feel? Next time, never I will come to this shop. This is what comes to your mind. So suppose if that work is done maybe in 10 to 20 minutes to the maximum and you get the dish for your food. So what do you say? Because after what you say is going to prepare. Maybe the preparation time, there is some optimization in the preparation time and the serving time. There is more than one service person, maybe 4 to 5 service providers are there, that is bearers or someone. So there are so let us assume there are 4 to 5 tables. Only one server is there to take care of all the 5. It is hard for everyone to be served in the right time. So there should be a multiple server. According to the situation, we have to plan how many servers to be there, and according to the chairs available, according to the arrival rate of the customer, we have to plan what strategy to be done. To take care of the customer. To take care of the customer. The same thing happens in every industry. Maybe you can take a bank, you are going for getting some money outside from your account and you are told, okay, you are taking the token system and you are sitting there. So they make a system. So you are given a token, you can see what is the token running now? It is 12 there. What is in my hand? It is 45. So just you can assume. So how many minutes I have to sit? So you have to see how many cashiers are there. So there are 4 cashiers. Okay, 4 cashiers with each one 4 at a time. So maybe I can go a little earlier. So your mind what it says. That's a streamlining of structures happening. Apart from this, just you think that randomly people are sitting. Whoever is talented can go first and get that work to be done. So that system fails. We need a proper system. We have to plan properly. So we have to see what is the arrival rate of the customer. Maybe maybe in weekdays in a bank, the number of customers may be less. Maybe in Saturday, the number of customers may be more. Similarly, when you talk about a barber shop, in Saturday and Sunday, customers will be more, but in between days, customers will be less. Again, in transport, if you say, in between the days, customers will be more, Saturday, Sunday, customers will be less. Am I right? But the long transport, no, Saturday, Sunday, customers will be more. So it depends on the scenario, variety of scenario. Am I right? So accordingly, we can do a lot of mathematical models. There are plenty of mathematical models based on the arrival rate, based on the service rate, based on number of servers in the system, based on the capacity of the system. Likewise, we can frame a mathematical model according to the scenario and we can view the industry. Okay, you can have this model, sir. Accordingly, if you go, you can best suit for your system and you can make as many customers satisfied, because customer satisfaction is very, very important. The customer should not wait for your service for a long time. He has to be served as much as possible. This can be applied even in a traffic system. In a traffic system, when you are when you are traveling the road, you can see there is a signal with you can see one side the number of seconds will be less, one side the number of seconds will be more. There will be some variation. Why that variation? It is a big structure. They would have there might be a survey, like how many vehicles are going from left to right in this area, from front to back in this area. So they will analyze from this road to this road. So in this connectivity, only these many of cars or bikes are going in this particular time. So accordingly, the time system can be varied so that You should be, suppose you think like you don't want to wait for a long time. As soon as you go there, a particular time will run. Accordingly, the traffic will go down. It will cross. If that is easy, that is the situation. So we like that system, or else no one is going from left to right, but you are told to wait till the total number of seconds goes. You will be tense, You might not follow the rules then in future. So this mathematical modeling concept of queuing can be applied in industry to solve real-time problems and get suitable solution using the right model. Okay, I think you are understood what I tried to tell you. Thank you.